Hi you guys, welcome back to my Crypto 101 series, and today I'll be going over Hedera, or also known as HBAR. Now, while HBAR is not technically a part of the top 10 cryptocurrencies, I wanted to go over its overview and its utility and things like that because I really feel like it's a very special coin, and a lot of major institutions and enterprises have already adopted this coin, and the only reason I feel like it's not a part of the top 10 yet is because it is relatively new, okay? It was just born a few years ago. So with all that said, we'll go ahead and hop into it. But before we get started, welcome back to Getting Digital with Deja. So I know I said I would be only doing one video per crypto coin, but I lied. This coin needs two videos, and the reason why it needs two videos is because of its consensus mechanism. Okay, it has this thing called Hashgraph, which I really want to go over in deep detail because while HBAR is the only cryptocurrency currently that uses this, it is an alternative to the blockchain system. So other coins in the future could potentially adopt this same exact type of consensus mechanism. So I want you guys to know exactly what it is, how it works, and really have a deep understanding of it, just in case in the future Hashgraph becomes super popular and is running neck and neck with blockchain. So I'm going to go over the textbook definition of Hashgraph. Instead of using the computational power of large networks to verify transactions, transactions are recorded and confirmed via a protocol that uses node communication. Hashgraph consensus is reached using gossip, gossip about gossip, and virtual voting. Now I have an even deeper dive of a definition for this just in case that didn't make sense because you're like, gossip about gossip? What the heck does that mean? I got you. Similar to blockchain, it stores and encrypts data. A hash is generated for transaction info, and new transactions or data are added and built upon it. However, a blockchain is a ledger that consists of blocks of data. Each block is linked to the previous block using its data, verified by a network of validators to create the next block. This process creates one chain. A hash graph isn't one chain. All info is kept on an encrypted ledger, and every user participates in the validation process, not just the validators. So that's where the idea of gossip about gossip comes into play. Everybody on the network is contributing to validate these transactions. It's not just the validators. So you're going to be needing information and gossip from a lot of people on the system, on the network, to be able to validate these transactions. So let's give a real life example of this. So we have Marcus, and Marcus is creating a transaction with Jamal. So all the info that Marcus has, he's sharing it with Jamal. Now Jamal is going to go and create a transaction with Kim. All the information that Jamal has is going to be shared with Kim. Now Kim has all of that information. Now Kim is going to go share her information with Carlos because she wants to make a transaction with Carlos. Now Carlos has all the information of Kim, Jamal, and Marcus. Okay, so essentially what's happening is they're gossiping with each other, quote unquote, sharing information from one person to the next. So it's like a history of transactions, but it's not necessarily like a blockchain where there's just one chain. It's all being communicated by people on the ecosystem, on the Hashgraph type of network. So there's no need for computational validation. And the reason that is because all the nodes communicate with each other. They tell each other the transactions passed on from one down to another. So there's no need to validate it computationally. So that literally like X's out a whole bunch of energy that the blockchain would have used if it's going to be validating and using validators. Okay, so instead these validators, or we can call them nodes, are going to be communicating with each other, gossiping to each other, and just spreading each other's business essentially. And that's how these processes in these transactions are going to be validated and encrypted and placed onto the ledger. And the network uses a lot of different algorithms and automations to be able to make sure that everybody's ledger is exactly the same, to make sure that it's secure and that all the information is accurate. So referring back to the first part of the definition that I gave you guys, I mentioned something about gossip. Now I'm going to go into the textbook definition of what gossip means for this HBAR network. Information about data is called gossip. I said gossip. Information about data is called gossip. The data structure contained in a transaction are a timestamp, more transactions, 2 hashes from the parent containers, and an encrypted signature. The 2 hashes are the last events from 2 syncing nodes that compare their info. Nodes are continuously creating events in syncing. The ledger is more efficient than blockchain because no energy is wasted on blocks that aren't accepted. All information is retained in a hash graph. So as you can see, it's very, very similar to blockchain, yet very, very different. So I'm going to use the example of Bitcoin. So I taught you guys all about Bitcoin and how they use the hash functions and all that to create the blocks and all of that. If you don't remember, or if you haven't watched that video, click on that video after this so you can have a way better understanding, okay, you guys? But so essentially what happens with the blockchain for Bitcoin is that it has these blocks, and inside of that block it contains like information, okay? They call it the candidate block. So it's going to have the timestamp, it's going to have the quantity, it's going to have also as well the previous transactions, which is why they call it blockchain, okay? So those blocks are considered transactions, and those chains connecting those blocks together are the previous transactions, okay? So those are the previous transactions hashes, all right? So that's what creates that blockchain. Again, I go over that in full detail in my other video. Go ahead, click that if you want to understand that more. But for those who do understand, we're gonna move on. So it's essentially very similar with this H-bar network, but it's not all just like connected by one chain, essentially. So the last 2 syncing nodes are sharing their information with each other and comparing that information with each other to make sure it's accurate and to go ahead and validate these transactions, okay? So you don't need the computational power of a whole bunch of nodes on the network to make this happen, because everybody as a collective is making this happen, okay? So that's why it's more energy efficient than the blockchain system, which is why I wanted to talk about it, because maybe one day we're going to be like, oh my gosh, we're using too much energy, we need to stop, okay? Because computational power is actual real life energy. AI data centers and all that, they use real life energy, which is why they have to have water. I don't know if you knew that, but AI data centers and just AI in general uses a lot of water. We will get into that another day, but yes. So if we want to go to a more energy efficient and less time consuming type of process, Hashgraph would be the answer to that. Now let's move into the second part of that previous definition that I gave you when we first started off, which is going to be gossip about gossip. And I'm going to be explaining what I mean more in detail about the nodes syncing with each other and sharing information. Info about transaction data is called gossip about gossip. Info is synchronized in the Hashgraph network using an event called gossip sync. A gossip sync is a collaborative history of gossip events throughout the Hashgraph. Therefore, data cannot be altered or tampered with, and there is a consensus. So, like I said, this network is syncing the data from one node to another, from one participant on the network to another. And so that just makes it way more collaborative. So because it's collaborative, that means that it cannot be tampered with, because everybody on the network is going and giving their versions of the data that they receive from one of the nodes. And obviously, all the data has to be the same. It has to line up with each other. If one node is saying something and it doesn't line up with all these other hundreds of nodes, then they're going to be like, okay, your data is different because we all have the same thing and we were all given the same information. Why is yours different? So that creates a consensus inside of the network. So you may be thinking, okay, how do they exactly come to a consensus? And that gets into the third and last part of our definition, which is going to be virtual voting, okay? Now, this is different. This is really interesting. It took me a little bit of a while to grasp what it meant by virtual voting, because I'm like, how is that possible? But it's definitely possible. Okay, so now we're going to go into the textbook definition of virtual voting. And don't worry if it doesn't make sense. I'm going to give you another definition in simple terms. Virtual voting occurs when the nodes compare events and reach a consensus via a voting algorithm. A transaction is assigned a timestamp as a node receives it. As it passes it to other nodes in a network, it is assigned a timestamp that is a median of all the other timestamps for the transaction received by the nodes in the network. The median acts as a result of the vote. This creates a more fair transaction system than a blockchain because the network decides, not the node. So here is the simple terms definition that I made. The Hashgraph algorithm does not require any votes to be sent across the network to calculate the votes of each member. Members can calculate every other member's votes by internally looking at each of their copies of the Hashgraph and applying their virtual voting algorithm. Votes are calculated locally as a function of the ancestors of a given event. So these nodes can eternally look at the data of each other's hash graphs, okay? So they can see the transactions and things of other people's hash graphs of what they have, the history of their events, compare it with their own or compare it with others. And that's how they come up with a vote. There is not just a vote that is submitted to the system, for each node to be like, okay, I validate this, I agree with this, blah, blah, blah. No, it's not like that. They're coming to a consensus, comparing each other's like hash graph information, their data, and that is how they come to a consensus. They're not racing to see who can do it first, so that they can be rewarded on the system. They're not essentially staking a whole bunch of cryptocurrencies to be able to do this in the first place. It creates a more fair and just environment. They're just sharing and comparing information with each other to be able to get these transactions submitted, okay? And so when I was talking about the timestamps, being a median for the transactions, everybody compares their timestamps with each other, and it's all put together, and they create a median from those timestamps, okay? So everyone might not have the same exact information, but they're going to create a median from all those timestamps that were created, and that is going to be submitted to the network. And that creates a lot more security within the network, because you got to think of it, when there's malicious nodes on the network and they're submitting a different time step or a different time value that is crazy, way off crazy, trying to manipulate the network, it won't work, because there's all these other nodes on the network who are submitting their timestamp information, and it doesn't match, and it's a median of all of them. So that one that's super wrong and malicious is not going to overthrow all of the other hundreds of timestamps that were submitted and voted on, essentially. So it creates a more stable and secure sense of network, because when you have blockchains, traditional blockchains, a miner is typically the one who will assign a timestamp to that transaction, and that miner node could be a malicious miner node, okay? But when you have a collective of data creating a median timestamp, that eliminates all of that. So talking about malicious nodes, that brings me to the point of the Byzantine fault tolerant. Now, this right here is different, okay? This right here is really different, because it really just makes it to where it is so hard for any nodes to be malicious on the network. Okay, well, rephrase. It doesn't make it hard for them to be malicious on the network, but it makes it harder for them to get whatever they're trying to be malicious about, like, achieved, okay, essentially. So I'm going to go to the textbook definition of what I mean when I say that. Byzantine fault tolerant, or BFT, is the property of a distributed system that allows it to reach consensus and continue operating correctly even if some nodes act maliciously, fail, or send conflicting info. Hashgraph consensus can tolerate 1/3 of the network acting maliciously, which means that honest nodes on a network continue working even if there are bad actors. That basically means that one man cannot stop the show. The show must go on, and the show will still go on no matter if there are malicious nodes on the network, because it is a collective set of data that is being sent and put onto the ledger. Now, the crazier thing about this is the 1/3 part. So that means that 1/3 of the network can be acting maliciously, and the network will still go on as if everything is going correctly, because their data, the 1/3 data, will not inflict or depict anything that is happening with these transactions, because all the other nodes are continuing on with their day. And 1/3 is a huge number, okay? That is a huge number. So that means that there can be a lot of malicious nodes on the network who are trying to do something maliciously, come up with a group of people who try to make something happen, something shake on the Edge Bear network, and it still won't work, because the network will still keep going, and it still will keep pushing out these confirmed and accurate transactions, because it has the collective data of all the other good nodes on the network. Other major crypto networks that use BFT are going to be Solana and Ethereum. Now, technically, Bitcoin is supposed to be using the BFT as well. That's how it's described by Satoshi in its white paper. But it doesn't really use that. It doesn't really use BFT, okay? It uses proof of work, mainly majority, okay? So Bitcoin and a lot of other crypto networks have a problem with message timing. But this BFT protocol essentially eliminates that problem by essentially saying that, okay, any delayed or missing transactions are going to make it to their destination eventually. So that is how they combat the message timing. So what I mean by that is, on other networks, when you have two transactions happening simultaneously at the same time, what's going to happen is the blockchain is going to do, a couple of options. One of the options is going to be, it's going to prioritize the transaction to get confirmed first by how much people have staked. Okay, so how much validators have staked, that is going to be able to push their transaction faster. Or another way that the blockchain is going to do it is by fees. They prioritize people who tip more. Okay, so the more you tip, the more priority tip that you give these validators on the network, the faster your transaction will go, and it's most likely going to be confirmed a lot faster than somebody else who didn't include all of those transaction fees inside of their transaction. In both of those situations, one node is essentially influencing the outcome of the transaction, of the confirmation. Okay, and that is not okay. We're not going to be confirming other people's transactions faster because they paid more, or confirming them faster because they have more cryptocurrency staked. That's not fair. That is not fair. That is not true peer-to-peer network behavior. Because if you remember, on a true peer-to-peer network, everyone is seen as equals. So how can you possibly be seen as equals if transactions are being confirmed because this person has way more cryptocurrency staked, or because this person paid more in transaction fees? Hashgraph eliminates the possibility of one node or a group of nodes having an influence on the transaction confirmation. And this essentially is because the timestamp is created by all of the nodes on the network. It's a collective of their data on the network that creates this median for the timestamp. There's not one node or a group of nodes who are essentially contributing to the network and saying that this is the timestamp. So that is it for today's video going over Hashgraph, and I will be going over HBAR, actually going HBAR, the cryptocurrency, in my next video. And don't miss that video, because big companies like Boeing, Google, Nvidia uses HBAR. It is taking over the crypto world, okay, you guys? So go ahead and tune in for that video once I post it. But before I let you guys go, remember that pretty girls can do crypto too. Toodles.